Welcome to Chapter 17. We've been dealing with waves, and when we talked about waves, we studied really two things. We studied sound and we studied light. And sound interaction kind of occurs with your ears and whatnot, but light interaction, we're going to really dive down into how light interacts in two ways. Well, there are three ways in which light, or any wave, can move, really. It can reflect, refract, or diffract. And what we're going to focus on in chapter 17 and 18 is how light reflects and how light refracts. How light reflects is through mirrors. So chapter 17 is going to focus on mirrors. Now 17.1, there are two types of mirrors. There are flat mirrors and there are curved mirrors. And we are going to start our introduction with flat mirrors. To begin, a flat mirror is much more simpler than a curved mirror. The properties surrounding a flat mirror are much easier to understand than a curved mirror, and a curved mirror kind of has a couple complications that come with that. So when we talk about plane mirrors, first mirror invented in 1857, which really isn't really an invention, it's more of an application of current technology. Mirrors have been around a long time due to simply panes of glass or metals reflecting things. We have talked about the law of reflection already. The law of reflection is very simple. The angle of reflection equals the angle of incidence. So in the blue here, if I have a flat mirror, what's coming in at green, that is my original incident ray, my reflected ray is coming back out at the same angle. Remember, if we draw a line perpendicular to our plane mirror, which is my dotted black line, that is called the normal. This angle in red is equal to this angle in green, and they are angle of incidence equaling the angle of reflection. That is the law of reflection. We'll study that in a little bit. When we talk about surfaces, a flat mirror can kind of have two surfaces. It can have a specular reflection or diffuse reflection. Now, what's the difference between the two? A specular reflection results from a smooth surface. The parallel light rays are reflected perfectly, like a regular flat mirror. One that's probably in your bathroom is a great example of a specular reflection mirror. Diffuse reflection is a rough surface, or the surfaces are kind of jagged, or I should say rough. A bike deflect, or a reflector on a bike has these prisms. And I shouldn't say prisms, but these little small areas where it's kind of bumpy and helps reflect light in multiple scattering ways rather than just one way. So we have specular reflection, cannot talk today. Specular reflection and diffuse reflection. Now, when we talk about mirrors, there's a broad list of vocabulary that we are going to talk about which explains mirrors. And these concepts are going to apply to both flat mirrors or plane mirrors and curved mirrors. So when we talk about a plane mirror, what classifies a plane mirror? It's essentially simply this. It's a flat, smooth surface which can reflect light. That's all a plane mirror is. You've seen plane mirrors all the time. Most likely in your bathroom when you're getting your hair ready or makeup or whatnot in the morning. That's a plane mirror. Other words which apply to mirrors. Object. The object, let's put it this way in a plane mirror. The object is you. You are the person. You're the object. That's where the source of where the light rays are coming from. You are the object. The image is what you see in the mirror. That's the object in the mirror. So when you are looking into the mirror, you see an exact replica of yourself. That is your image. You are the actual object. And we're going to talk about object and image when we talk about curved mirrors also. Then, depending where the image forms, depending where the light rays diverge or converge, depends where that image is necessarily projected. If that image is projected on the other side of the mirror, if the rays meet on the other side of the mirror, it's called a virtual image. If the rays meet on the front side of the mirror, it's going to be called a real image. Now we are going to work on diagrams light ray diagrams when we start talking curved mirrors. And it's possible for the light rays to meet on one side of the mirror or the other. Again, to reiterate that fact, when an object appears on the opposite side of the mirror, it is a virtual image. When the rays diverge or converge on the opposite side of the mirror, it's a real image, a virtual image. If they are on the object's side of the mirror, it is a real image. So we're going to talk real images versus virtual images. Again, virtual images on the opposite side of the mirror, real images on the same side of the mirror. So when we talk about properties of plane mirrors, we're going to talk about two key things: mirror image position and image height. So we're going to talk about whether the image, we're going to talk about how far it appears away from the mirror and the height it appears in the mirror. Now, in a plane mirror, what's neat is if you are about a foot away from the mirror, what does your image appear to be? About a foot away on the other side of the mirror. So we can put that into an equation. The distance of the image is equal to the negative distance of the object. Again, why do we have a negative sign? The negative sign is indicating that the image is virtual into the mirror. Likewise, when we talk about height, if you stand in a full-on plane mirror, are you the same height as is your object, the same height as the image portrayed in the mirror? Absolutely, with a plane mirror it is. So we can say HI is equal to HO. The height of the image is equal to the height of the object. So two equations that we tie together. We have image position and image height, how far away it appears. And that's a distance, di is equal to negative do, and the height, hi is equal to ho. Now a couple more things on image. Plane mirrors produce an image with the same orientation as the object, so everything's going to look the same, nothing should change. There's more on page 463 in your book about this, but really the key concept from today is the two equations we just got done talking about. Distance image is equal to negative distance of the object for a plane mirror, and hi is equal to ho, along with real versus virtual images. Virtual images are on the opposite side of the mirror. Real images are on the same side of the mirror. We'll talk about this more. If you have questions, we'll have some problems to go over, along with we will further our explanations when we talk about curved mirrors in section 17.2.